Okay, let's unpack this. Imagine, if you will, a manufacturing facility. Now picture this. Every single component, from the tiniest screw to a massive assembly, has its entire life story. From the moment it's ordered right through to its final delivery at the assembly line. Documented, clear, and like instantly accessible, all in one place. Sounds like a bit of a fantasy, right? Well, today we're diving deep into something that makes that real. It's a powerful tool called PFAP, or Plan for Every Part.
It's funny you say fantasy because it's such a critical need, but yeah, so many organizations really wrestle with it. The reality is that information often exists somewhere, but it's scattered. Siloed across countless departments, different spreadsheets. Sometimes it's just in someone's head.
Right, tribal knowledge.
Exactly.
Yeah.
And that fragmentation makes informed decision-making incredibly difficult.
Hmm.
So PFEP isn't just about collecting data. It's really about transforming that data into actionable intelligence, centralizing knowledge to drive genuine operational excellence.
So our mission today is basically to pull back the curtain on PFEP. We'll explore what it is, why it's such a game changer for material management, and then walk you through the practical, step-by-step way it's implemented. How to create that lean, super efficient system, all based on the comprehensive sources we've dug into for you. Okay, so let's kick things off by maybe shining a light on the core problem here. The thing PFEP is really designed to conquer. Think about all the critical info for every single part in a, say, complex manufacturing operation. It's often kind of invisible, isn't it?
Oh, absolutely. Invisible or just scattered.
Yeah, like one bit might be with production control, another bit's with purchasing, engineering's got some specs, and then, like you said, there's that crucial knowledge held by experienced folks on the floor.
hmm
This kind of fragmented data is just a massive headache. It makes it nearly impossible to see the whole picture for a part, how it's bought, how it arrives, how it's packaged, where it's stored, and, how it finally gets to the line. It's like trying to navigate in a thick fog with, like, a really blurry map.
That fog analogy is spot on. And it's not just an inconvenience, it's a huge productivity drain. If you connect this to the bigger picture, you quickly realize that without this single, undisputed source of truth, setting up a truly lean material handling system is just an incredibly tough uphill battle.
Yeah, makes sense.
This lack of a central, accessible hub for part info inevitably leads to constant inefficiencies, frustrating delays, and this kind of perpetual cycle of reactive problem solving. Instead of proactively optimizing, you're always chasing information, always putting out fires.
And that's precisely where PFEP steps in, offering this promise, right? It acts as the gateway, really, to operational excellence. Once it's set up properly, meticulously established with accurate data, and diligently managed, it can completely transform how a facility operates. It enables that truly lean material handling system.
And the practical benefits, the tangible stuff, it's significant, and you often see it almost immediately. First, PFEP pulls all that crucial real-time data on every single part into one place. One easily accessible hub. No more scavenger hunts across, endless spreadsheets or different departments.
Okay, that alone sounds huge.
It is. Second, and this is really powerful, it gives you robust sorting capabilities. Imagine being able to instantly categorize parts by, say, container size, or by the supplier's location, maybe usage frequency. This capability is just invaluable for strategic planning, for optimizing your logistics.
Right, so you can see patterns you wouldn't otherwise.
Precisely. Third, it ensures you get rapid, accurate answers to pretty much any operational question about parts or suppliers. That dramatically cuts down decision-making time. And the impact isn't just stuck inside one building. PFEP actually helps extend your lean system beyond a single facility. It can encompass plant-to-plant material movement, helping forge a more cohesive, efficient supply chain across your whole network.
Those benefits are really clear. But I'm curious, for an organization just starting out, what's usually the biggest hurdle they face? Getting to that centralized data point, and how do they even begin to overcome it?
Yeah, that's a great question. The initial hurdle is almost always the sheer scale of the existing data, which is often disorganized. And honestly, getting buy-in across different departments to commit to that meticulous data collection effort.
Right, the human element.
Definitely. The way to overcome it, as our sources really highlight, is by first developing a clear, strategic implementation plan. Before you even think about building the database itself, you need to map out your future state.
Future state. Okay.
Yeah, so this means clearly identifying how material will flow through your plant, determining the number, and crucially, the strategic locations of your supermarkets.
Supermarkets, like for parts.
Exactly.
Yeah.
They're essentially dedicated, optimized storage areas. And you need to define how both the physical materials and the information will flow in this ideal future state you're aiming for.
So capturing that current state snapshot, really understanding where you are now, that's truly non-negotiable before building anything new, correct? What's maybe the most common blind spot or like unexpected challenge companies hit when they're trying to map out exactly where they are?
Absolutely. The current state is the essential baseline. A common blind spot is uh, underestimating the complexity of what seem like simple material movements,
Yeah.
or maybe not realizing just how much artificial storage or handling is actually happening out there.
Oh, the workarounds?
The workarounds, exactly. One of the most effective tools for creating this comprehensive plan is to develop a value stream map, or VSM.
CSM. Okay.
Think of a VSM as a detailed map. It visually charts the flow of material and information right from the moment an order is placed all the way to its final delivery. You typically start with a simple current state connection map.
Go.
This involves identifying all your production steps, understanding exactly how material is currently stored. Is there too much, too little? Is it just in the wrong place? Detailing the existing delivery processes and clarifying who is responsible for what right now.
Right. Truly understanding the messy reality before you try and improve it.
Precisely. Once you have that baseline nailed down, the next step is creating your future state VSM. This map illustrates what needs to be done. It defines your planned supermarkets, specifies which product families go where, pinpoints delivery locations, and outlines exactly how production will be scheduled and material delivered to each user location. This whole general plan is the indispensable precursor before you even, open up Excel or whatever to start the actual PFEP database.
So what does this all mean then for building the actual PFEP? Once you've got that VSM, that vision, you can then begin constructing the database itself. This is where you really capture, well, everything about every single part you buy or make.
That's the core of it, yeah. The PFEP is typically managed in a spreadsheet or maybe a dedicated database. Lots of places start with Excel because it's accessible, but the ideal scenario, and our research backs this up, is to integrate it directly into the company's MRP or ERP system.
Their main business software.
Right, those central platforms that manage inventory, manufacturing, everything. Now, a critical principle here, a real game changer according to the sources, is loading data in the smallest element possible.
Smallest element, what do you mean?
Okay, so for instance, instead of having one column for container dimensions like 12 by 10 by 8, you create separate categories: height, length, width. Each gets its own column.
Ah, okay. Why is that so important?
Because that granular breakdown isn't just about collecting more data points. It's the lever that lets you surgically optimize every inch of your storage, your line-side presentation. It directly impacts throughput, space efficiency. It's huge. Similarly, breaking down supplier addresses into city and state allows for really powerful sorting, especially if you're planning external material movement systems like milk runs.
Milk runs. Those scheduled pickup routes.
Exactly. Highly optimized, scheduled routes picking up from multiple suppliers. That detailed address data makes planning those feasible.
That granular approach clearly unlocks powerful sorting. But does it ever present challenges, especially during that initial data collection phase? I mean, how do companies manage the trade-off between all that detail and just the sheer effort of capturing it?
Oh, it absolutely can be a challenge up front. It requires meticulous effort, no doubt. The key is really to start small and then scale. The process usually begins by populating the PFEP with data from just one cell, maybe one production line. Then you systematically expand cell by cell across the entire value stream until it covers every part in the whole facility.
Right, bite-sized chunks.
Exactly. And our sources highlight several crucial data categories you need to collect in this current state. Remember, the goal isn't just data for data's sake, it's data for insight. So for part information, you're thinking foundational stuff. A part number, any specific customer part number, a clear description, the part name, and crucially, is it something you make or buy? These details build a unique profile for each component.
The basics.
The basics. Next, container information. This gets incredibly detailed because container design is just so vital for efficiency. So you cover the container type. Is it cardboard, a reusable tote, a wire basket, whatever, whether a standard pack quantity is used, the actual quantity per container, any specific container instructions like returnable or recycle, and then precise measurements: container weight, part weight, full container weight, and like we said, the container's length, width, and height. Getting these right directly impacts your space and handling costs.
So those individual dimensions really give you the flexibility then to adapt your layout, not just sort of blindly accept a container's whole footprint?
Exactly, that's the power. Then for shipping information, you're tracking the rhythm, the logistics.
Hmm.
Order frequency from the supplier daily, weekly, the lead time both in days and weeks, the carrier, transit time in days, shipment frequency, even the typical shipment size and days of supply.
Yeah.
You also note if an inspection is usually required for that part, which flags a quality control point.
Okay.
Supplier information profiles your partners. Supplier name, are they external or internal, their city, state, country, and even supplier performance metrics, things like on-time delivery and quality ratings. This helps you manage your supply chain proactively, not reactively.
Good point.
Consumption information gives you that clear picture of usage, monthly, daily, even hourly usage in parts, the number of containers used per hour, and usage per assembly, like how many of this cart go into one finished product. This data is what drives your inventory planning.
Makes sense.
Then part readiness. Here you assess if the container is truly line ready or supermarket ready, flagging any improvements needed. And critically, whether repacking is required before storage or delivery, that points right to a potential waste that PFEP can help you eliminate.
A big one, usually.
Often, yes. Finally, cost and inventory information. This dives into the financial side. The item class, usually based on dollar value, its category often ABC, that common way to classify parts based on value and usage frequency, your high-value runners, mid-range repeaters, low-use strangers.
Right. Prioritizing effort.
Exactly. Also the item cost itself, cost per container, and your monthly inventory costs. This helps you really understand the capital tied up in all these parts.
It's clear that while these are, common categories, the PFP really needs to be flexible. You have to be able to add or remove things based on a plant's specific needs. It's definitely a living document right from day one. And this isn't just one person filling out a spreadsheet, is it?
Oh, far from it. Our sources really stress the importance of cross-departmental review. Production control, material handling, engineering, quality, operations, purchasing, sales, marketing, accounting, all these functions need to review and basically sign off on this information.
Wow, that's a lot of cooks.
It is, but the true insight here isn't just about information sharing. It's about forcing a shared mental model across all those critical functions. It prevents those departmental silos from accidentally sabotaging a unified lean strategy. Their collective buy-in, their agreement, is absolutely crucial.
Okay, so once you have all this rich current state data, you've got that shared understanding of what is, you move into what sounds like a much more exciting phase, planning what should be. This is really where the plan in PFEP comes alive, right? Turning all that raw data into actual strategies. The initial data collection probably uncovered a ton of discrepancies and opportunities.
Indeed. Now it's about correcting those problems you found and actively developing that future state plan. This involves asking some really critical questions that directly guide your operational design. Things like, how much inventory should we actually keep at the supermarket? What's the optimal maximum level? What are the precise reorder points, that minimum level that triggers replenishment?
Okay.
What are the standard pack quantities we should enforce? Where exactly should each part be kept in the supermarket? Its specific storage address. Is the current container really right for the line, or does it need repacking? Hey, could the supplier maybe even be persuaded to do that repacking for us?
Pushing waste back up the chain.
Potentially. And on the delivery side, where exactly is the part delivered at the line, its specific line address? How much inventory should be kept at each line station? What delivery method makes sense? A structured milk run? Maybe something else. What's the reorder quantity and frequency? And how many Kanbans, those visual signals for replenishment, are needed for that loop?
This clearly isn't just a desk exercise then. This is where you really need to get out there and talk to the people on the floor, the warehouse folks, material handlers, the line employees themselves. They're essentially your customers in this whole process, aren't they? What are some common insights you get from those direct conversations that might not just jump out from the data?
That's a fundamental point, absolutely. Their insights are just invaluable. You'll hear about the workarounds people use, which expose hidden wastes, or you'll get suggestions for container modifications that make presenting parts genuinely more ergonomic, safer.
Yeah, the stuff you only know by doing the job.
Exactly. To formalize these plans, you then add more fields to the PFEP database. This turns it from just a data repository into a dynamic blueprint for the future. For your supermarket storage plans, you'll specify the supermarket name, its precise storage location, and any specific supermarket instructions like how to present parts, how to stack them efficiently.
Getting really specific.
Very specific. For inventory reduction and control plans, you'll document crucial targets. The target maximum cost of inventory for a specific part, the XX and MIN number of containers you want to keep in the supermarket, the reorder point, minimum order quantity, and various levels of buffer, cycle, and safety stock, usually measured in days or weeks. These metrics become the foundation for truly lean inventory management.
Right, controlling that capital.
And your delivery plans become incredibly precise, too, outlining the exact delivery address on the line, the max inventory allowed at the line, the chosen delivery route and method, the delivery frequency. You'll also include details like where the empty returnable containers go, the number of cards needed in the Kanban loop, the specific Kanban loop name, maybe even how many containers are needed for 1, 2, or 4 hours of inventory right there at the line, and any special delivery instructions. These are all those meticulously planned future state details that turn your data into truly actionable, optimized strategies.
Okay, so you've built this incredible system. You've created your future state plans. Sounds great. But a PFEP isn't a static document, right? You called it a living thing earlier. It continuously needs updates, modifications. How do you stop it from just becoming outdated the second it's implemented?
That really is the crux of long-term success, isn't it? The integrity of the PFEP absolutely has to be sustained through relentless, ongoing maintenance.
Yeah.
Just consider the constant flux in any manufacturing environment. Continuous improvement efforts will, hopefully, eliminate repacking, reduce inventory with smaller, more frequent deliveries, maybe change storage locations or delivery addresses.
Sure.
Suppliers will alter their delivery schedules or maybe change container types. And new products, new parts, they're arriving daily. Without a really robust, dedicated system for updates, the PFEP just quickly becomes obsolete. And you're right back in that foggy state we started with.
Yeah, all that work wasted.
Exactly. To manage this dynamism, our sources strongly recommend appointing a single individual as the PFEP specialist. This person is solely responsible for maintaining and updating the PFEP.
One person.
Usually, yes. This focused responsibility is critical because it prevents the information quality from deteriorating if too many people can make uncoordinated changes. Interestingly, it's often not a full-time job, maybe 10 to 30 minutes a day, depending on the plant size and complexity. In our experience, fewer specialists usually mean a more accurate PFEP simply because there's a clear chain of accountability.
A dedicated specialist definitely brings consistency. But what about the risk? Creating a single point of failure. How do organizations make sure there's continuity, knowledge transfer, if that specialist, say, moves on or is out?
That's a vital concern, definitely. And it's typically addressed by two key things. First, really robust documentation of the PFEP process itself, not just the data. And second, having a formal system for managing change. Our sources really emphasize instituting a guideline that every new part or any significant change to an existing part must be documented in the PFEP and approved by that PFE manager before it ever appears on the shop floor.
Okay, a gatekeeper.
Essentially, yeah. This is where a PFE change add request form comes in. It ensures the PFEP is always up to date, and crucially, it creates an auditable paper trail of all changes. This prevents those uncommunicated modifications out on the floor. Think about it. Your production control team might rely on the PFEP for accurate supplier locations and lead times. Industrial engineering uses it for container dimensions to design parts presentation devices. If these groups could just change info willy-nilly without a formal process,
Chaos.
yeah, the data quality would just deteriorate rapidly. It undermines trust, efficiency, everything.
This raises an interesting question, though. All this work, the development, the constant updating of the PFEP, is that itself considered a lean activity? I mean, does it add direct value from the customer's perspective?
That's a great nuanced question.
Yeah.
And it's important to be clear. No, strictly speaking, from the customer standpoint, it's not a direct value-creating process.
Yeah.
The customer isn't paying you to manage your internal data.
Oh.
However, it is unequivocally what we call important incidental work. It's work that significantly increases the percentage of value-creating activities throughout the entire plant. Without a distinct, accurate, and accessible PFEP, all sorts of wastes searching for parts, overproduction due to bad info, quality issues from wrong components, they become practically unavoidable. Think of it as the essential engine that powers the lean machine. It provides the timely, accurate information that value-creating activities simply cannot function efficiently without.
Got it. So it enables the value add.
Precisely. It's foundational.
Okay, so to wrap up our deep dive into PFEP then, what are the absolute non-negotiable keys to making this system a success for you, the listener, if you're thinking about implementing this?
Right, to boil it down to the absolute essentials. First, select a PFEP format that inherently has strong sorting capabilities. Whether that's a sophisticated database or just a really thoughtfully structured spreadsheet, sorting is key. Second, always load data in the smallest element possible. Remember the container dimensions, 3 separate fields, not one combined one. That unlocks maximum flexibility.
Okay, smallest element.
Third, and this is critical, appoint a dedicated PFEP manager, someone solely responsible for its accuracy and updating. Clear accountability. Fourth, establish precise guidelines for controlled maintenance. Dictate exactly how information can be changed, by whom, under what circumstance.
The process part.
The process part, exactly. And finally, institute a formal system, like that change request form we talked about, to systematically capture and approve updates to the PFEP. These 5 elements really are your non-negotiables for maintaining integrity and achieving sustained success with PFEP.
So what we've unpacked today, it feels like far more than just talking about a database. It's really a strategic framework for truly mastering your material flow, isn't it? Transforming all that scattered information into a powerful, agile operational system. It's about taking proactive control, really, of your entire manufacturing environment, one perfectly managed part at a time.
Absolutely. PFEP fundamentally shifts an organization. It moves you from constantly reacting to material issues to proactively planning and optimizing every single component. It's about empowering every single department with the right information at the right time so they can make genuinely lean decisions. Ultimately, that drives greater efficiency, reduces waste, and builds resilience across the entire operation.
So here's a thought to leave you with. Think about the products you use every single day, maybe your smartphone, your car, anything complex. How many hundreds, maybe even thousands of individual parts go into making them? Now, just consider the sheer complexity of managing all that information for every single one, and how a meticulously well-implemented PFEP could be that hidden engine working behind the scenes, ensuring their consistent availability, their quality, and ultimately your seamless experience as a consumer. Now, what aspect of your own work, or maybe even your life, could benefit from a similar plan for every part approach to information? Where could bringing that kind of clarity and control help you manage your own complex systems more effectively?